Hi, now let's look at projectile motion, which is an application of 2D motion. For now, let's assume that there's zero air resistance, there's a constant downward acceleration equals to g, and that the forward acceleration equals to 0. So here we have an object being thrown at an initial velocity of u at an angle theta inclined from the horizontal plane. The ux can be calculated by taking u cosine theta, while uy can be calculated by taking u sine theta. This object will take a parabolic path, and at this point you see over here, velocity in the x direction remains constant, vx equals to ux, because my horizontal component of acceleration equals to 0, but vy changes because there's a downward acceleration, and vy can be calculated using uy plus at. So here are the equations which are applicable. For the y component, all the four kinematics equations remain the same, but for the x component, you realize that vx equals to ux no matter what point it is, and sx, which is the horizontal range it covers, is equals to ux multiplied by t. And at the highest point, note that my overall v is just equals to ux, because at this point of time, my instantaneous vertical velocity is 0, but this does not mean that there is no acceleration. From this point onwards, the whatever object will travel downwards, and when we resolve it, vx is still equals to ux, but now vy changes direction.